chain me on the same page. We are effortless, schemaless, living in the future. You and me, made for us, serverless, living in the future of the clouds.
Hello, good morning, good afternoon, good evening, wherever you are. Glad to be back from a vacation last week and, to be doing this workshop. We always get a lot of international audience. For those of you who are here for the first time, welcome. For those of you who have been here for multiples, welcome back. My name is Rags, and Stefano, do you want to say hi to everyone? And make sure if you can put a thumbs up that you're hearing two voices once you hear Stefano's, and no more than two voices, there are no echoes, anything like that. We want to make sure that, you have a good experience for the next 2 hours.
Yes, thank you, Rags. Hi, Rags. Hi, everyone. Welcome to today's workshop. Please tell me if you can hear me as well. And Rags, maybe I think you left the music on. That might
Thank
be
you.
a bit, low volume, but I hear the music. We keep the music for the quiz.
We save it for the quiz, right?
Yeah.
Yeah, exactly. All right, we can't give it away now.
Thank you, Rommel. We hear you. The music
you.
should be off now. Sorry. Okay, so I think everyone noticed the music. I think we are good now. What do you think?
I think we're good. Yeah, I turned it off.
Okay, great. So again, hello everyone, and I think we can start. Someone says I might be made a bit louder.
I can try that. Yeah, I can definitely do that. All right.
Yeah, it was fun music. Music will come back. So, okay, I can start now. Hi, Alex. It's nice to see you in the chat as well. Okay, so let's go. I think you're showing my screen. Probably.
Looking good. You are nicely placed.
So,
I'm nicely placed as well. So we'll keep going.
So, introductions. I'm Stefano. I'm glad to be here. We will have fun today and learn a lot. I'm a developer and architect at DataStax. Actually, I'm a developer advocate here at DataStax. I know Cassandra. I love Cassandra. I love distributed systems, and I love to teach. So today, by the way, we are going to speak of some other topics, namely AI and machine learning, which is also a very fun and cool topic. So join us in our journey. And to you, Rags.
Thank you, Stefano. And my name is Raghavan Srinivas. And for whatever reason, a lot of people in the world have a tough time pronouncing my name. So I just go by Rags. Easiest way to remember me, Rags not to riches. And I'm in different forms, slightly different from, in LinkedIn, I'm Rags. On GitHub, I'm Rags and S. And on Twitter, I'm Rags S. But in the end, I'm Rags. I'm also, like Stefano, a developer advocate at DataStax. And, I come from more of a Kubernetes, Java, that side of the world. I've done NoSQL also quite a bit. But one of the things I like about the workshop is that no matter what your level is, our goal is to up-level it. And I myself learn by attending the workshops, by teaching the workshops, and so on. And one of the main passions that I have is kind of improving the developer productivity by making the inner loop easier. Today we will kind of touch upon it. There is a new, really new trend that's emerging in machine learning called MLOps, where you have all these operations that are associated with machine learning. But from a developer perspective, we want to provide that as an API, and that's exactly what we'll see today. So although we will go into some aspects of ML, we will focus really mainly in the operationalizing ML part of it as well. Okay. All right. With that, Stefano, back to you.
Yeah, good point. Thank you. So I see Aris writes that he or they like the lightsabers. So maybe next slide is for you, because you can guess these workshops are not just the work of the two of us, but there is a whole team behind, and it's good to acknowledge all of them. So this is the full team, and you see we all have lightsabers.
And there are quite a few who are not even included here, right? We still rely on a lot of help from them. Basically in pushing the content out, making sure swag is sent, and things like that. A lot of things, that happen behind the scenes.
Yes, absolutely. So there is a whole team, and we have to thank all of you. And by the way, some of you are in the chat. So, okay, so let's start with the topics. First, we will see a few practical advice for today's live and how to follow us in this hands-on workshop. Then we will quickly view what is the main goal of today, and then we will take a look at the database side of today's application. Then we will look at a few important points about AI, and we will start training the model, which is then brought to production within an API. And then we will close with a bit of fun and a bit of let's say, closing words. Okay, so I think we can start with the housekeeping. So this is live, and there will be a bit of hands-on. So briefly, what are the tools we use today? First, you are watching us live, presumably on YouTube. But in case YouTube would fail, which happens a few times, let's say 2 or 3 times per year, we will head to Twitch, which is our plan B for the streaming. That's one thing. Then, on YouTube, there is a chat box, and I see you are all very active there. That's good. And that's a good place to ask questions. But we invite you to join us on Discord, because Discord is the place where the discussion can continue and also touch on other subjects when this live is over. So please join us on Discord. We will maybe paste the link in the chat just for you to join us, because we invite you to join us there. That's not the end of it, because there is also another kind of interactivity. We will do quizzes, we will do a bit of games with prizes later, and for that we will use Mentimeter. We will give you the link in a little while. Okay, so now more to the point. Today we are going to do a bit of live hands-on exercises, and you are going to do that with us. For that, we have a few resources. And first thing is, there is nothing to install. It's all in the cloud. It's all in your browser. So nothing to install. Of course, if you feel more comfortable, you can also decide to do that on your PC, as long as you have, Python, and you have Git, and basically that's it, and an IDE maybe.
But okay, just to make it clear, since we have about 400 people, looking at this workshop right now, we want to be able to support the majority experience. So we will not be helping you. Not because we don't want to, but because it takes more time to do it locally. So our recommendation is to use Gitpod and instructions that are provided that we'll see in a moment.
Yes, that's a good point. So we will not give you live support, live troubleshooting if you decide to go on your local machine, but you can, and we will be reachable on Discord later if you want. But as Rags just mentioned, today we are going to use an IDE in the cloud, which is Gitbot, which is very cool, and it will automate most of the cloning and the running of code for us. We also will have a database as a backend for data persistence. For that, we will use Astra DB, which is based on Apache Cassandra, and it will provide each one of you with your own database, with your own NoSQL database as a service in the cloud for free. So that's it. I have to mention, because a very important thing, most of the content of today is based on original content by the coding entrepreneurs, developer, influencer. And the content is different. There is less in the two versions, so to speak. So you are invited to visit their YouTube and their blog, because you will find more parts, different usage of several tools. So all in all, you will learn a bit more. Okay. So I think that's it for the introduction.
Aditya had asked a question about how long is this workshop. This is 2 hours. Sometimes we have had Eventbrite calendars being off a little bit, but again, if you cannot stay on for the entire 2 hours, and remember we have some fun stuff at the very end, right? Still, it's all recorded, and you can come back and watch it later, and do it yourself.
Yeah, definitely. One thing that I want to mention is that we will soon give you the link to the GitHub repository. There you will find detailed instructions that, by the way, cover also the case of local running. And all in all, they will contain far more details and information that we are able to convey in 2 hours. So you are invited to go there and maybe, deepen your knowledge. Okay, so I just pasted in the YouTube chat the link to join us on Mentimeter, and I want to start the presentation.
Okay, I'm gonna go to two small heads. If anybody, has any issues with sound or anything, let me know, because I just changed it a wee bit.
Okay, it should be okay.
All right.
Yes, I think it's all right, sound-wise. Okay, so please join us on Mentimeter. So you type menti.com and enter the code that you see here in the chat, 6010-6344, or you can scan the QR code, because this is the platform we will use to ask you a few questions. First, it will be initial questions just to get to know our audience better. And later, the same platform will be used for the quiz. So for the quiz, it means that it will be timed question with prizes and all that, but not yet. An important point is that now, as well as later, please do not answer in the chat and do not watch YouTube for the questions, because there is a bit of delay, and the answers you type in the chat will be wasted. So please use menti.com. Don't look at YouTube, but look at Menti. Now, let's see. We have many people join already, but maybe we can wait a few seconds more. Let's wait for 200 people on board.
Let's
200.
do 200. Come on. Yeah, we're there. All right, we are 200.
Sorry, I alternate between the two views. Okay, so it's still time for you to join. Maybe I will repeat the link on the chat. But let's start. So let's start. Okay, so these are just a few questions to get to know you better, to know our audience. So first, we want to know, where are you watching us from? So where in the world are you from? Let's see. I see lots of people from India.
Quite a few from Canada. Wow.
Some points from Africa, Canada, a lot. Brazil, United States, Mexico, all over Europe.
Man,
welcome everyone. Nice to see. There's a nice
no matter how many times you see this is so exciting, because it's so nice to interact with the international developer community, knowing fully well that as much as you learn from us, we also learn from you.
Yes, and so again, please do not use the YouTube chat for
please
these
don't.
answers because they are wasted answers. So it is a pity, especially later because there will be the quiz. So by the way, kudos to India because I understand it's a bit late
Yeah.
there, if I'm not mistaken. So congratulations. But okay, we have a lot of people from all over the
Do we
world,
have somebody
and
from
let's move
China
on.
there?
Sorry.
Could that be new?
Yes, I've seen, yeah, I see one
Okay,
point
that's
from
cool.
China. Now, what is your role as a developer? Front end, back end, more web apps or data engineer, cloud native developer, DBA, or other? Well, other is really means many possible, but I see most. Yeah, that is to be expected. Most of the attendees are data engineers, so backend, that kind of backend, or other, which yeah is sort of
Yeah.
umbrella option.
I mean, the other could
Nice.
be a
Well,
real estate developer, you think? I'm just kidding.
yeah. But it's cool to see also front end developer. I mean, the interest in these topics is really transversal. How do you say
Okay.
widespread kind of interest? So
So,
that's
so we
good.
have a comment. This is a great workshop, but we really need to get to point. We'll get to the point. The idea is that some people might be arriving late, but point well taken. Thank you.
Yeah. Okay. So we will start shortly. Don't worry. What is your primary programming language? These questions are also aimed at tailoring
Presentation. Yeah.
our content to be better and better next time because we run a series of workshops and every week we want to give you the best possible experience. So that's the point. I see, well, that was expected. So the vast majority are proficient with Python, and that's good because today is Python. And I guess for most of the data science, data-oriented coding out there, it's Python. So no surprises here. And I want to move on. So today, your primary interest is more the AI machine learning or how to put models in APIs, all of today. Are you here just because you're curious? Or maybe you are here for the swap, which is our world famous swap.
We have 3 people admitting
Okay,
that they are here
so,
for the swag. That's cool.
well, I appreciate
Honesty.
your
Yeah.
honesty.
Exactly.
Yeah. Oh, yeah. Cries in R. I know. Yes. R. I should not have. I should have mentioned R. I agree. But okay, it happens that today we are focused on Python 100%. So, okay, but it's cool to see that it's also here a nice distribution. Now, a flame provoking question. Python scripts or Jupyter notebooks? So do we prefer Python scripts? Do we prefer interactive computing? So Jupyter notebooks and shift enter all the way to the end of the cells? Or do you have a moderate position? So there are different tools for different tasks? Or you really don't know what this question is about? So that's interesting. Jupyter. Yeah, okay. I see Jupyter, let's say interactive computing wins over ordinary Python scripts.
Yeah, it's very, very, very.
Okay.
Yeah, I mean, I think
Yeah, well, by a factor of 2.
each task the right tool,
Write
I
my
think
own tool. I
is
like
pretty
this
good answer
answer.
anyway, right? So,
Okay. Okay. Yeah, okay. That's good. We will keep that in mind if we have time to go the Jupyter way, but I wonder if there will be time.
last question, I
Yes.
guess, right?
Okay, so do you know machine learning?
Last question, is
Sorry?
it? Yeah,
Sorry?
almost there.
Yeah.
Almost there.
So, do you know some machine learning? I see there are some very expert. I eat Kaggle Masters for breakfast. Good to know. Total beginners. I've had some exposure. Okay, so of course we tried to tailor today's content to an average kind of audience. So you will see. I'm sure every one of you will find something that you don't know, and it might be good to add to your tools. Okay, so
So I think Nitish
yes,
makes
last
a
question.
point. It's
Sorry.
really fun here. I didn't expect this. Keep going, and I think that's one of the differences in our workshop is we expect you to chat, but we also expect you to kind of not chat when we're going to go through some practice, and we'll talk about this when we come to that. But feel free to ask any questions, especially if you're stuck.
Yeah, absolutely. Okay, so I see most of you are new. Welcome. So this is the first workshop of ours that you attend, but maybe not the last. We'll see. And to those of you who have already been to our workshops, welcome back. And today is new content, so I hope you will be having fun. There is a question on certificate. Yes, there will be a badge if you complete the. So besides attending the workshop is not enough to have a badge. There is also a bit of lab to submit. So I will tell you later. There is a submission form in the README for doing a bit of a work of your own, a bit of coding, and then you submit a homework form. We will grade it, give us a few days, and you will get a badge, which is a verified attendance badge. So it works as a certificate that you attended and did the homework of this workshop.
So we
the lab.
might as well
Okay.
preempt a question or answer. One of the questions we get is, when can we submit the homework? We recommend 1 or 2 weeks, so that it's still fresh in your mind, and by repetitions you get the concepts better, right? But you really, if it's not possible in 1 week or 2 weeks, it's okay. A little bit, a few more days is fine. We recognize that we are all talking to professionals. With that said, Stefano, back to you.
Yeah, that's a good point. Okay, so let's start. I take a note. Let's start with the content. Okay, so what is our goal? Very broadly speaking, we want to create an API that exposes kind of task. So what we want is our customers or our web application or maybe our internal other microservices, they want an API that they can query with a question. In our case, it's going to be a classification question. Namely, I give the API a piece of text and I ask it, is this spam or it is a legit piece of text? Let's say these are messages, email subject, SMS, whatever. And the API does its magic and it will reply, yes, it is spam with 96% confidence, or no, it is not spam, it's okay. So this is what we want as seen from outside, right? Okay, so the API will be sitting, if you want, on top of a machine learning thing, a machine learning classifier in our case. And so today we want to learn two things. First is, well, not in order, two things. One thing is we want to learn how to take a machine learning classifier and properly expose it as an API in a production kind of
So Stefano, let me preempt you.
Yes.
There is a question about what the heck is that API thing in the middle, right? I don't think you expanded what API, and sometimes we make this assumption, but thanks for
good point.
Bringing us to task. API stands for
Application Program Interface. Okay, so it is a service that is reached by usually HTTP requests, and it will accept request, do some processing, and respond with an answer. So I think we will see it at work later, but in general, it is something that might be used by front end, by another service that needs to query it. Let's say you have a complex data pipeline and you need to filter spam messages as one of the steps in your process pipeline. You might have a separate service just working to do that. So you have let's say you're running a data ingestion service that gets more and more pieces of text, but it has to filter out spam. So this is a service that your main data pipeline might have to query systematically to make sure it doesn't include spam messages, for example. So actually, the API might be exposed to the outside, might be part of your internal pipeline. It might be directly exposed to customers, to clients, to whatever. Okay, so I think we will actually run the API and run a request to it. So I think it will be clearer in practice. Okay, so from the standpoint of the API, the AI part, so the classifier, is best seen as a black box. It is something you put text in and you get answers back. More or less, that's the way. And this is the side of today's concern with the serious engineer kind of guy you see here in the picture. He's very serious. He's production guy. He wants stability, performance, and maybe is not even so much concerned as to what is the inner working of your classifier, because that's stuff for another guy here, the crazy mad data scientist. So now I'm making it a bit funny today, but actually it's two different two different kind of people here, two different jobs. In general.
I don't think it's the serious engineer, because he's wearing a suit. How can an engineer be wearing a suit?
Yeah, okay. These are just pictures, but I don't even think many data scientists have to wear goggles or lab coat, but still that's funny. And that's the mad scientist. And it's still data science. I mean, it's engineering, probably it's mathematics, but it's science. And as such, it is experimenting, prototyping. It is a discipline that is very much evolving, and a lot of dead ends, a lot of attempts, experiments. And this, unfortunately, sometimes shows in the code, which is a pity, because sometimes the machine learning components you see around are hidden treasures that maybe are hard to reproduce. They are not always polished and ready for production. They are hidden in notebooks, maybe, and similar things. Now, today, we want to bridge the gap. We want to make these two people speak to each other. Actually, we want to be both people at once, because that's something that emerged more and more in the last years. It's not enough to have cool machine learning models. It's also important to be able to use them reliably in production, to expose them the right way, to promote interoperability, open specifications and whatnot. There is not much use to a very cool model if the only way to run it is in a notebook hidden somewhere in my own personal folder with a lot of caveats. Run this cell before this one and then go back. I mean, the usual real-life messy things that you probably have seen, maybe you also have done. You can
and also, if you go back to the
the
developer inner loop, where you do this edits, debug it, profile it, and so on, you will do the same thing in machine learning as well. You will be building training models which take much longer. So you want to streamline this as much as possible, and that's kind of what you'll see in today's workshop, is being able to bridge the gap, like what Stefano was talking, between the ML consumer and the ML producer, right? So that's really what the goal is.
Yeah. So okay, I see the chat is becoming a very funny place, and that's great. Of course, now trying to be serious again, 1 second. When we explain, try to keep your questions a bit, because we might be giving you the answer later. So let's try not to get distracted too much, of course, with limitations, because we will not be able to pay attention to so many of you very well. So let's go ahead. Maybe what I mean is that maybe most of your practical questions will be answered in the practice part, because we will have time to inspect a bit of the code and see how the main bits work. Okay, so very generally, this is the architecture we have in mind when we want to build this API. There are requests coming from outside and hopefully getting answers, and that's one point. The API will have access to two things. There is the machine learning model, which is, you can call it model or classifier. It is the thing that the crazy scientist prepares and then hands it to the serious engineer, right? So this model or classifier is now in the hands of the API code, and the API is able to use it to query it, to run it against any new text that arrives and give the answer back. But that's the main operation. But in most cases, maybe not much today, but in general, running a classifier model on new input is expensive. It takes time. It takes CPU. Maybe it might take a few seconds. So many models, as this one, for example, they work deterministically. So once they are loaded, they will give always the same answer for the same question. So why don't we cache the results? And indeed we do. That's why we also have a database here. And the database will be used as a cache for previously processed inputs. So every time an input arrives, actually what we do is we look into the cache, and if we have a result, we serve it, done, very quick. If there is no result, we run the model for real, we serve the result, but we also cache this result for later queries. Again, whether to do this or not depends on many considerations. One is how expensive is it to run the model? Sometimes it is very expensive, and I mean seconds sometimes, many seconds, because there are very complex models. There is another question that is, how often do we predict the same input will be submitted more than once to the API? And in this case, probably it will be submitted multiple times, because let's say this is a service to tell apart spam email messages. So usually spam comes to very many recipients. And if suppose this application is used in a way that every individual recipient will query this service, so we will have a lot of requests with the same input, and then caching is more and more relevant. So I see a question in the chat. Here we use LRU cache, LRU cache. Now, actually, we cache everything. So in this model, in this simplified model, we just cache everything because we use a database that has a lot of space. And we avoid in-memory cache because we can restart the API, and we don't want to lose the precious effort spent so far. Okay, so you see, you just saw the architecture, and let's have a look at the technologies that we will use to create this. Okay, so basically, as maybe that's an answer to someone asking what an API is. Requests and responses to and from the API will be served through HTTP ordinary request, so HTTP protocol. And then the API is written in FastAPI. FastAPI is a modern framework for writing API in Python. So it supports a lot of cool features. It's aimed at reducing the amount of boilerplate to the minimum possible. FastAPI, in turn, will be run using the UVcorn runtime, which is, let's say, it supports modern protocols for running Python APIs and speak HTTP on the other side of things. The model is a Keras model. So there is a very cool machine learning library called Keras that is now completely part of Tensorflow. Tensorflow is a library for machine learning and, let's say, in general, vectorized computing, written at Google, and Keras is an interface, is now, let's say, a layer on top of it that makes it easier to, let's say it makes it for a higher level abstraction on top of TensorFlow, very much familiar to neural network and similar classifiers. Okay, so the last point to observe is the database. The database is going to be AstraDB. I mentioned that already. AstraDB is a database built on Apache Cassandra, a NoSQL database. And it has the advantage, besides being free to use for us today, it has another advantage. It is very good at scaling. It has very many nice features that we are going to briefly mention in a while. But most important, it is in the cloud. So it is offered as a service. So we will get our own database with a couple of clicks and no operation, no maintenance, no deploy needed. So ready to go.
So I think, Stefano, there are a couple of questions, one from Gautam and one from Huisan. Essentially, what about other technologies? Obviously we could pick another database. We could pick another, technology for doing APIs. Do you want to touch upon that a little bit? And, this is something that we picked because it's kind of easier to use, right?
Yeah. Okay. So, maybe part of the answer is going to be in the next slide. So maybe let me go forward. Okay, so indeed, we are at section 3, database setup. Okay, so let's start with Apache Cassandra. Apache Cassandra is an open source NoSQL database on which AstraDB is built. Cassandra is, let's say, something that you install if you want on your machines. So as opposed to a database as a service, but the principle is the same. So Cassandra is distributed database. Data is distributed over several machines. It is able to deal with very big amounts of data, and it has astonishing read and write performance. Not only that, but it can scale easily. So if you need double performance, you just double the number of machines hosting the data, and you will have double performance. So that's what is called linear scalability. So there is almost no overhead because of its architecture. For similar reasons, so I mean, the architecture also implies that it can be configured to have basically zero downtime, so very high availability. It is good at self-heal when, let's say, there are some nodes that have been down for some time and they need to catch up with the data. Cassandra can be also configured to be geographically distributed, so you can have data duplicated all over the world to better serve your customers. It is platform agnostic, so it is not tied to any particular platform. So you can run it in your machines, in your data center, on AWS, on Google, Azure, whatever you want. Also, you can also have a hybrid deployment, and it is it guarantees no lock-in because it is open source protected by the Apache license. So the main answer to the question why Cassandra is very good at handling very large amounts of data with a linear access time. So regardless how many rows you will have in your cache, you will always have the same time to access them. Writing to them is very fast, which is important because we want to serve our results very fast without wasting time in caching, because that's not something that benefits the customer who made that request. So it makes no sense to give him a penalty. And yeah, that's it. So another point is that the particular usage we do of Cassandra today is not very much tied, does not require many relations between data. So if you think of a relational database, there's nothing like that. We just have basically a couple of tables that will act as a key value store. And this is where Cassandra shines most because it is absolutely super very fast in that. You will soon see more on that. Okay, so, well, now we spent a few words on Cassandra, and let's see what AstraDB is. AstraDB is a database in the cloud. It is built on Apache Cassandra, so it inherits all of these nice features I just mentioned, and it is just handled as a platform for you in the cloud. So no operations, no maintenance. Not only that, but there is a lot of further ways to interact, a lot of tools. There is also a message, an event streaming platform coupled to that. There are all sorts of ways to interact with AstraDB. So not only the Cassandra drivers, which we use today, but there is also REST, GraphQL, gRPC, etc. Document API, I think MongoDB. So there is a whole ecosystem ready to be used there in the cloud. Today we use the ordinary basic Cassandra way of speaking to the database, namely we use the Cassandra drivers. That's because there is complete compatibility. So there is not such a thing as the AstraDB drivers. You just use the Cassandra drivers. Okay, so that's good. That's an important point. And it is something that we will get ready to use with a few clicks. Now, before going on, I would like to show so today is not about databases that much, but we are going to use a database. So let me spend 5 minutes on some peculiar features of using Cassandra as a database, because it's cool and because it's good to know. And if you ever plan on writing an API like the one we are seeing today, that is very useful knowledge, probably. So we are going to do two things with this database. One, as I mentioned already, is we want to cache predictions. By the way, you might wonder, what is a prediction Well, a prediction is actually what the model gives us when we give it a text. So you remember this, it's spam 96% confidence. This is the prediction. So it's not a prediction like the weather forecast, but in machine learning, it's always called prediction, meaning the response from the model, okay? So you remember in the architecture sketch, we want to store predictions in the database to be able to later query them for serving them if they were already processed. There is a second usage we want to do for of the database, and namely, we want to log calls. We want to keep a record of the calls issued, the request coming from particular clients, particular agents requesting from the API. Let's say we want to do that for, I don't know, to compute pricing in a specific way, or we want to implement rate limiting or whatever. So we want to keep a log of every individual call issued by users. Okay, so these two queries, so these two usages of the database become two different queries. So what do we want to ask from the database? First, tell me if there is a prediction for this input text and this model version. Let's say this is always going to be V1, but maybe in the future we plan on deploying a new classifier, a V2 of the classifier, and we want to keep the two entries separate in the cache, because you remember every time I give the same input, I get the same output. But if I replace V1 with V2, probably this will not be true in general. So we want to keep them separate. The other question, the other query we want to run on the database is, tell me all calls that this person, this IP, this client IP, basically, has issued in the last hour, or in this hour chunk. Now, a point of Cassandra is that first you look at the needs of your application, and then you design the table. Another point is that every table is distributed. So table is made of a lot of rows, but these rows will be grouped in several machines that form your database. Okay, that's something we unfortunately we can just touch briefly today, but still I want to show you that looking at these two queries, we come up with two different tables. One is called spam cache items, and it will host the already processed pieces of text with their result, their prediction. And the other is spam calls per caller. You see so these two, here you see a schematic view of the structure of the two tables. You see there are some columns, so model version, input, confidence, and so on for the cache, and caller ID, caller hour, and called at, which is a full timestamp, and the input text for the second table. Now, the meaning of those is actually, those are called Chebotko diagrams, and this is how you model your data in Cassandra. We will just gloss over these points, of course, but the important thing is that as many other databases, there is the concept of primary key. So you have to pick rows, columns that ensure every row is uniquely determined, as these three in the purple box. But also you define something called partition key, which is a subset of these columns, of these rows, sorry. And these determines how the data is physically located over several nodes. Now, that's just a detail, but it's an important detail because it basically determines what kind of queries I can run in a short, and I can run quickly, and I can run and have the result quickly. The meaning of this KKC is specific to these points. So K and K define the partition key, and the C means this is part of the primary key. Of course, this is something we have to touch very quickly. So primary key is concerned with uniqueness of rows, while partition key is what determines how physically the data are stored together. So what rows are grouped together on a single machine, and that implies which are the queries that go fast, because they just go to a single machine in the database. Okay, so I feel a bit sad because I have to go on. Of course, Cassandra and data modeling with Cassandra is a very cool and interesting topic, but we have to skip. And if you are curious, you will find a few more links in the GitHub repository and in many other of our workshops. But I'm afraid it's time to move on. I wanted just to pique your interest in Cassandra. We will use it later. So I just want to say something on the code, how the code uses this database. There are various ways of accessing Cassandra, or AstraDB for that matter. What we do today is we use the drivers, but the drivers in particular offer a nice abstraction that is made of objects. So you see here, we can avoid speaking the low-level language of Cassandra, and we can just define. You see, okay, I'll go through the 4 blocks of code here. In the first one, you see we define a class, a special class with some particular properties, and that's something we define once. And this is where we imply the shape of the table, of the underlying table. But then we never speak of tables anymore, because after making sure we initialize things properly when the API starts, and this sync table takes care of creating the underlying table. After that, we want to read and write objects to the table. We just create objects as we create ordinary Python class instances for reading and for writing, and that's it. So we just speak the language of ordinary Python objects, and everything else, the access to the database, is handled for us behind the scenes. That's cool because we don't have to take so much care of the underlying low-level parts of the database, but still, that's an important point. You can't avoid thinking of your data model, because if you get your data model wrong, you will have suboptimal performance. So you still have to think carefully on how to plan your tables, but then in terms of usage in the code, you just use ordinary Python objects, and that's what the object mapper does for us. Okay, I think I've been speaking enough already. So Rags, I suggest we go with the first part of the hands-on. So let me that would be an ORM, except it's not relational. So it's just object mapping. So no R, no relational, because the underlying is not relational. It's a NoSQL database. In particular, it doesn't know the concept of relations proper. So I think now the YouTube chat should give you the link to, okay, that's there already. So Rags, do you want to take over and start the demo part, or?
Yeah, absolutely. I'm
Okay.
good. Yeah. I think there is a lot of activity and chat about horizontal scaling, vertical scaling, and all that. And I think,
Yeah.
Stefano, you talked about this. There are several workshops that go into quite a bit of detail
Yeah.
on all this. Intro to NoSQL, intro to Cassandra, data modeling, you name it. We have workshops that go for 2 hours, so there is no way we can cover all that. So we'll just point you at that. But do you want to take up one question, which is like, why do we want to cache both the text and the prediction part, in the database? Yeah, maybe if you want to do that, I will be ready to go.
Yeah. Okay. So why do we want to cache both the input text and the prediction?
Yeah.
Well, that's what we need for the cache to be later used as a cache. So let's say tomorrow the API will receive the same input text as today. So I first have to look into the database and see if there is already a row with that input text. And this can hardly be done unless I stored the input text. Not only that, but I better store it in a table where the input text is part of the primary key. So this is also specific to Cassandra, but it's not so specific. The best way to look up a row is if I look it up by primary key. So I can go straight to that one row, right? So if the primary key includes the input text, I'm done, because I can really fast, I can reach the proper machine in the database, which is many machines. I can reach the proper node and find out if there is that input. Yes, that's a good point. So it cuts down computation cost by showing previous results if it's available in the database. But then once I know that row exists, I have to read the prediction that I wrote yesterday in order to, serve it to the caller. So I have to store both the input and the output. Think of a key value store. So I'm using that table exactly as a key value store, where the key is the input text and the version of the model, and the output is the result of the computation. So I can avoid repeating the computation.
Yeah.
That's more or less the reason.
Yeah, and there are some answers in chat which kind of point to that as well. So this is great. Thanks for helping us out with the chat as well. But let's get started.
Yeah.
I know that all of you are kind of waiting to get started. Typically, I mean, there are a number of ways of doing this. I like to kind of put this in different tabs. And you can see here, I start with my GitHub repository. If you don't know where the GitHub repository with all the instructions is, just type bang gitpod, or bang GitHub, or exclamation GitHub in YouTube chat, and you should be able to get to this repository. Okay, so I get to this repository, and then the instructions are pretty straightforward. I just kind of follow step by step. And if for some reason I get lost somewhere, what I can do is I can start from the beginning. We have enough time for you to get started and so on. But just follow it step by step as much as you can, right? So the first thing we're going to do is create the Astra DB here. So let's start, right? Create inside of the Astra DB. A number of ways of doing this. Again, what I typically do is I just use the open link in new window. Okay, you can do it wherever you want. It doesn't matter. Okay, it'll take you to the sign in website, right? And essentially what you can do here is you can put in your email, password, nothing else, right? No, we don't ask for credit cards, nothing. You can get quite a bit of significant credits to be able to use it. No promotion code, nothing. Very easy. Just put in your email, password. I've already put it in, right? So what I'm going to do is I'm just going to sign in. Okay, I'm going to sign in here. And you should be able to see your dashboard. Okay, so I already have quite a few, databases up and running, right? So you'll see that some of these are in active mode and some of these are in standby mode. If they're in standby mode, you can wake them up, right? That's what we recommend. But I'll get to it in a second, okay? But basically, you want them to be active, like Workshops is. And if you click on Workshops, there are a number of key spaces. We want you to create a key space called spam classifier, and we'll look into that in a second. Okay, so let me get rid of this window and go back to my instructions, right? So what I'm going to do is I'm going to create an Astra DB instance with the database name as Workshops and this key space name as spam classifier. Do you absolutely need to have the same names? Not necessary, but it's just easier that way. Okay, so let me sign in here. Okay, and go back to here. Okay, and you will see again. I'll see my dashboard. Okay, and let's go back. I just switch between the tabs, right? This is my Gitpod window, which we'll see in a second. Okay, and I'll make sure I open it. I'll come back to that in a second. And what I do is I switch between these tabs, right? I switch between the GitHub tab, the Gitpod tab, the Astra tab, and eventually you'll get to the browser as well. So that's just the way I do it. You can have multiple windows, you can have multiple browsers, and switch between browsers, whatever works for you. Okay, so let me not beat that to death. So once you're done this, right, what you need to do is you have to generate and download a secure connect bundle. Okay, so to be able to download a secure connect bundle is pretty straightforward. Make sure you have workshops, right? And then what you're going to do is you can say connect, okay, and then what you can do is you can connect using a driver. It really doesn't matter which driver you're going to use. You can see here, it'll give you Java, C++, C Sharp, and so on. You can pick whichever you want. Python is fine. You download a bundle, and all that you do is download and say secure connect bundle, and it will download the bundle locally. Okay. Once you have downloaded the bundle, we'll talk about what you do need to do next. Okay. But for those of you who may still be creating a database, you just do a create database. The database name is workshops. Remember, right? And this thing is it spam classifier? Okay, and you can really pick any region you want. We recommend just using Google Cloud and picking something that's closer to you. So I'm based in US East, and I can click on this, and it hit create database, and you can see here it's a free plan, which actually enables you to run significant production workloads on this. I myself have never really had to, I can easily do all these workshops and do more without really having to do anything else. If you want it in multiple regions, you want it on a cloud of your choice, okay, then the easiest way is to put in your credit card, or you can even live chat and talk to our operators who are there really 24/7 and can kind of help you out. Okay. Anything I missed, Stefano? Or
I think that's it. So database name, key space name, and then you choose area, region, and you hit create database.
Yes.
So there is a question: do you incur cost on Google Cloud? No, you don't. So free plan is free plan, but to unlock other cloud provider, you have to speak to an operator and have it unlocked, and that's still free. So what is not free is the enterprise plan, which is very, very way beyond reasonable usage that you might want to do, especially today.
Exactly.
So that's really for enterprises.
For today in most of our workshops, you don't need to put in a credit card, but if you want, like I said, inter-region and so on, then you may want to put in your credit card or use a different plan. Okay. One other thing I forgot to mention was, if you want to get to the SQL console, you can just click on the workshop, right, and then click on SQL console, and this will bring you to the SQL console. For those of you who have used Cassandra before, comfortable with this, you can click on the SQL console and then run the SQL commands. These are very similar to SQL commands in a way, but it's different in the sense that this is for Cassandra. That was more for SQL, right? But you can kind of, if you never used SQL and you've used SQL, it's fairly easy to kind of translate those commands to SQL as well.
Yeah.
All right.
So if I may add a few things, because
Yes.
I've been keeping an eye on the chat.
Yeah.
So there was a question. My database is standby, so hibernated. Yeah, that happens to databases in the free tier. After maybe 1 day of inactivity, they get hibernated. And to wake them up, you just click on the SQL console, and there will be a message saying we are unhibernating your database.
Exactly.
And in a couple of minutes, refresh, and you will see, when you see the SQL console ready and working and the cursor blinking, then your database is back to activity. So it's really a couple of minutes. Another question, so you have created or waken up your database. You have probably downloaded your bundle. Rags, you've been showing that. There is a question. Okay, if your database is pending, then it's all good, because a couple of minutes it will become active. Now it's probably pending. It's being created, and it will become active in a couple of minutes. I see a recurring point in the chat, namely Secure Connect bundle download is blocked. And I think someone mentioned that Chrome is blocking it. That's, I have to say, new to me, but then again, I'm not using Chrome, so that's pretty strange. Yeah, Rags is showing what happens when your database is being waken up again. That is taking a couple of minutes or so. Now, another point is if you see your region being locked, you might, the quickest thing for today workshop is to just pick another region, and that would be good enough for us today. No, we don't have particular latency needs today, so no point in choosing a region on the other.
Yeah, if
there was another question.
if the
Sorry.
downloading the secure bundle is locked, what you can do is you can go here, and essentially you can say copy the link. So there are a number of ways of doing this. So let's say I have my Python driver, right, and then download bundle. And then what you can do is you can say secure connect bundle, and then you can copy the link, okay, and put it in another browser. Maybe that'd be more tolerant if you're getting to that point. Okay.
Yeah, so thank you, Aaron, for writing in the chat a link to a trick on how to make Chrome less fussy. That might help you guys using Chrome. There is also an important question, what's a key space? Because that's something that probably...
Oh, yeah, I didn't mention that. Yeah, go ahead.
Might be a question of you. So, okay, we instructed you to create a database and to create a key space. And a key space is just a logical grouping of tables. So today we are going to use a couple of tables in our database to store call log and cache requests. These we want to keep grouped into a single logical container, and that's what a key space is. So it's in other databases, this is called a schema. But I mean, that's not even so important today. It's just something that has to be there to contain tables. So a key space contains tables and other things, but that's no problem. Aaron, thank you for pointing that out in the chat. I'll voice your remark for everyone. When you download the bundle, please keep it as a zip file. No need to open it. You just take the full zip file and save it on your local machine, ready for later. Did you create a token? Maybe I missed that point.
I did not create token. Okay, so maybe I can go back and...
So that's the point,
yeah,
sorry.
Yeah, good point. Yeah, so let me go back.
It's basically a namespace. Yeah. Sorry, yes. So I asked, please, Rags, to show this other point.
So to be able to create a token, what I'm going to do is, there are a number of ways of doing this, obviously, like right? And, essentially I can go into organization settings. Okay, and there is something called as token management, as you can see here. Okay, pick token management. Okay, and then hit database administrator. There are different roles. You can fine tune the role. We just make it easier for you to just pick database administrator, and then hit a generate token. That's all you need, right? And what this is going to do is it's going to create a token for you for that, specific database. I mean, actually it's for that region, but it doesn't matter. And what you will do is, it'll provide you the client ID, client secret, and token. What you want to do is not leave this page until you have copied this. If you leave this page, then it's gone, and then you have to, generate a new one and all that. And typically what I do is I just say download, and once I download, essentially I will get this in like a Excel spreadsheet, which kind of looks like this, the role, the token, and all that, and then you're good to go. Just make sure that you copy it. Sometimes I copy it to a notepad, whatever works for you. But just remember, if you navigate away from this page, this is gone. You'll have to create it again. Again, no big deal if you navigate away by mistake. But ideally, you want to keep the client ID, client secret, and token in a safe place, because we're going to use this pretty soon.
Yeah, so thank you, Rags, because you also answered a question by Keras. So token will be downloaded as a CSV file. Yeah, that's the preferred way if you want, because as Rags said, this page will not be visible anymore when you leave it. Of course, you can also create a new token, that's okay. But the point is that creating the token and downloading the bundle, these two things solve two different problems. One, the token is to authenticate when you will later speak to the database. The bundle is a big zip file, big 12 kilobytes or so, a big zip file that you just download, and this answers to Yash. You just download it and keep it there for now. We will use it in a little while. Inside the bundle, there are all sorts of routing instructions, certificates, and everything, which basically make it. This bundle will be given to the Cassandra driver in your application, and it will know what to do. It basically opens the zip file and knows how to reach your database in AstraDB, because there is a system of proxies that will lead us too far away. But you need some specifications of certificates and proxy information and server names to reach your own individual database later through the drivers. But this will all be done by you with the Cassandra driver.
Exactly. Yeah. You don't even need to know which provider it is, automatically taken care of.
Yeah.
Okay.
So by this point, you should have a database, a token, in particular client ID and client secret. Today we are going to use those two, and the bundle zip file ready for later. Okay. Yes. So I see questions that are a bit. So someone is going faster than us. Don't worry, D37. Don't worry. This error, unfortunately, it happens. This is because Python dependencies are like a jungle. But don't worry, everything would work. I tested it today already. So then there is another question. I'm getting error when I'm connecting Git repo to your Git pod. Okay. So that's it. Sorry. Okay, lifetime of the token. The token will last forever until the day you revoke it. And if you ever happen to commit your token to a public repository, you probably want to revoke it, because with the token, everyone can, access your database, basically. Okay, how to create the token? There was the question. You can create the token in several ways. I'm answering with a link because I cannot go again through it now. You create the token from the AstraDB interface. You can click on your organization settings, token management, and then you can create the token. Okay. Assuming most of you have done this part, maybe we can ask.
Should we get a few thumbs up of people? Yeah. Even if your database is in pending state, put in a few thumbs up. We just want to make sure that this is done, because this is kind of as strange as it may seem, the most complicated part of the workshop. I mean, maybe there's one more, but once we get this through, then thereafter it becomes a little bit smooth sailing. So let's see if we get a few thumbs up. Okay, we got a few. Stefano, are you good to go?
Yes, we are good to go. Oh, okay, I see a lot of thumbs up. So database, token, and bundle. So we can move on. And we do that with the part on AI. So to load data, we don't need to load data today, because it will be our request to the API that will later write the rows into the cache and into the call log. So very good. The token has to be created with database administrator powers. That's because we want to use the fact that the object mapper is capable of creating the table for us. So we don't want to create the table explicitly. So that's an advantage. We skip a few steps. Okay, so AI. Let's see a bit more in detail how to train this text classifier. That will be the heart of the API. Okay, so let me first tell a little disclaimer. This section is going to take a handful of minutes. So this is absolutely not going to be a lecture with a lot of heavy mathematics that somehow contains the whole human knowledge on machine learning. So I want to set expectation right. We have a few minutes to speak on that. So that will be a very non-technical introduction to machine learning, focused on what we need today. Sorry about that. By the way, if you happen to recognize the guy in the picture, write it in the chat. You win some moral points for me, because that's someone who is very dear to me. And I guess some of you might be good at recognizing it. It's illegal to use image recognition software. Yeah, good done. Well done. Yeah, did you recognize the person or the formulae in the blackboard? Yeah, okay, very good. Congratulations. Okay, so this is not going to be one of those mathematics-heavy lectures, but we will try at least to make it possible for you to understand sentences such as this one. ML, LSTM, RNN for NLP. What does this mean? Come on. Okay, so let's start from the beginning. What we want is some kind of machine where we put text in and we get results back. No, we put a text and we get something like this: spam 096, ham 004. By the way, ham is, of course, the opposite of spam traditionally. So what is machine learning in general? Yeah, Abhishek, you know that already. So why are you here? I'm joking. Okay, well done. Good, Abhishek. So in general, machine learning is a very general term. It's not even easy to actually draw the boundaries of this concept. It's, let's say, a collection of algorithms that learn from data. So they improve as you give data to them. And the point is that you don't have to explicitly program them for that particular problems you have in mind. So they are general algorithms that will learn to solve your problem without being instructed explicitly to do so. Let's say it's a glorified statistical inference, right? So it's a very complex and specialized kind of statistical inference. And of course, it is built on a lot of mathematics: linear algebra, calculus, probability and statistics, and whatnot. Luckily for us, we don't need to have a degree in advanced mathematics to use them today. We just need to know what we are doing, because the tools are now mature enough to be easily accessible as nice to use packages, especially if you think about Python. Now, if you ever did a simple least square regression or a logistic regression, you already did machine learning. So that's really, there are really simple examples that you can grasp with your eyes. You can almost do machine learning by hand on a piece of paper. But of course, the real power comes when you have a very big kind of problem. And let's see more. Okay, today we are going to focus on what is called supervised learning, which is not the most general machine learning problem, because there are also many problems that are grouped into the unsupervised learning label, which means, okay, let's first see what supervised learning is. Supervised learning means that someone gives, we start with a model that is ready to learn but has not learned yet. And so we have to choose how the model works. Then we give the model examples of how to associate inputs and outputs, basically. In our case, we give the model a list of text and a corresponding list of whether they are spam or not spam. This is the sample. This is what is called the training data. These are the labeled data. No? This is known. It is a known association between input and output. And we want this model to adjust itself, to tune its parameters to best reproduce this kind of output given this input. But of course, it will have to, the model has a value when it is able to do, to solve this problem for new input, right? Okay, so this operation, giving a newborn model input label data and having it learn from this one from this set of points, and until the point it becomes able to solve the same problem on new input. This process is called training, and training essentially is tuning parameters, and tuning parameters in the direction of getting the results from the model as close as possible to the training data, right? That means that in supervised learning, the role of the mad scientist here is, of course, to choose the right model, because there is a lot of different models and a lot of different details and fine knobs to tune and everything to choose the right model. But then the crazy scientist also has to find and prepare and polish the training data to actually run the training. Now, the training is something that is run once in general. Let's say in typical cases, you run the training once. Then let's say this crazy scientist is satisfied with the results. It says, okay, the model is good enough. Then training is done. And then we have the final model, the one on the right in this image, which is then ready to be given to the serious engineer, right? Okay, so what is training? Training, again, is really just tuning the parameters of the model to make the predictions from the model as close as possible to the labeled input. That's, in general, how it works. So this is supervised, meaning that we give the model instruction on what it has what problem it has to solve, what the model has to reproduce to work. Unsupervised learning are problems such as I give a model a set of points and it has to find groups in them, no other instructions. Or I give the model a set of properties or features of, I don't know, a lot of features of a lot of individuals, and it has to find what are the important features to single out to best describe the differences in this population. So there is no training set, but just the data set to work on. But today we are going to stay on supervised learning. Supervised learning is in turn a big family of different models, very different from each other. There are a lot of them. Again, logistic regression, support vector machines, a lot of them. Today we focus on neural networks, which are very famous, very well known, and they are by no means the only machine learning algorithm that is there. So neural networks, well, they are somehow inspired by the way our brain is supposed to work. Indeed, neural networks are a simulated version of neurons exchanging signal somehow, as in a brain. So look at this nice image. We have we have some neurons in a real neural network. There are many more than this. We have some neurons, which are, again, simulated in your computer, of course, and they are connected by arrows. Arrows means that the signal moves from one neuron to the other in this pattern, or in some pattern. Every neuron is very simple. It will receive input from several other neurons. So look at the diagram on the right. Every neuron will receive input from other neurons. It will combine these inputs, these numbers. It will combine them according to some weights, some factors to multiply. And then it will emit a new signal according to some internal function. So basically, a neuron is very simple. It receives a number through different input legs. It will sum them, and it will emit a single number as output. That's it. That's what a neuron does. But a neuron has already several parameters, because there are weights, there is another parameter internally. So, but still the neuron is pretty stupid, I would say. It's really simple in its working. So the intelligence of a neural network comes from the sheer amount of neurons and the clever way they are connected to each other. Or, in other words, once the architecture of the network is chosen by the crazy scientist in general, the actual ability to solve your problem lies in the particular choice of these numbers, the numbers in purple here. And there are a lot of them. probably hundreds of thousands of them. So learning, so finding the best combination of this number is by far not a trivial task, even just for a computational reason. So in a neural network, basically the input is the first legs. Let's say in this diagram is on the far left. Input is encoded as signal entering the input layer. Then the signal propagates according to the rules of the neurons, and then you would hopefully read your answers as signal coming out from the output layers. So this is the general idea of a neural network. What you see here in the picture is a simple kind of network. So there are layers. Every arrow goes from one layer to the next. So the signal flows clearly in a precise direction. In this case, from left to right. But that's not the most general network, of course. Indeed, what you just saw is the architecture called feed-forward, which is easier to reason with, and it is something like lasagna because you have layers, and every layer is very clearly defined. But there are problems that somehow require more general architecture. Indeed, you can imagine having signal going back in the network or just going to the same layer somehow. And this has an interesting consequence. Okay, so this is a more general kind of relation between neurons. It is more like a tagliatelle dish, right? So you don't have any more neatly distinct layers. You have any general kind of arrow. And, okay. Sorry, Joseph. I'm not telling you what time is it here.
Me too. I'm hungry too.
Okay. I will quickly skip to the next slide anyway. But okay, the point is that as soon as you introduce loops in the signal propagation, you have a very big consequence. You somehow make a neuron able to remind itself later of something it knows. So you have introduced memory. Of course, this is just the idea, but these kind of networks that are the so-called recurrent neural networks, they are much better than the feed-forward networks at processing sequences. So a time series, a text, a speech, handwriting to recognize, this kind of sequenced input is very much better if you treat it with these kind of architectures. Now, there are all sorts of technical hurdles there, especially in learning with such a network, because advanced techniques are required. And in the landscape of recurrent neural networks, or RNN, a particular choice is made. So it's not the only one, but historically, a clever solution was invented to overcome a few technical limitations in the recurrent neural networks, namely the long short-term memory that someone mentioned already earlier. LSTM. So instead of relying on the loops themselves to somehow indirectly retain memory, the LSTM architecture directly encodes memory elements. So it has explicit elements that control remembering and forgetting, and they are directly tuned. Yes, so LSTM are great because of gates. And the gates somehow bypass technical problems in training mostly, and they directly control what is learned, what is forgotten for the next step. So they are easier. Their training has the hope to work in a shorter time, and shorter, I mean reasonable time. Okay, so of course this is very sketchy. You can see. Okay, so let's quickly spend some words on NLP, natural language processing. So being able to extract information from generic text is a very important business goal, almost in all fields of human knowledge, because most of human knowledge is there in unstructured form. It is just in text, and being able to automatically squeeze data out of it has a very high value. So you don't just have, spam classifiers as today, but you can have auto-completion, automatic translation, chatbot, or maybe today you would call them smart assistant or whatever, sentiment analysis, topic detection. There's a lot of things that you can do with such architectures when you approach text. And there is a lot of text with a lot of valuable information hidden in it. Okay, so the point is that LSTM are very good at things, at problems where there is a sequence to be analyzed. So for example, our text. Now, this is by far not the state of the art using just an LSTM. So there are newer advancements. I saw in the chat someone mentioned transformers. We are not going to use them today. We are trying to stick to something that is manageable in 2 hours of everything, including bringing to production. But yeah, there are modern recent advancements. Word2Vec was very famous at some point because it was a way to translate words in a semantically aware way. So for example, in this sample text, today we will just translate every word to a conventional number, and that's it. But Word2Vec would be probably translating free and gratis and complementary to very similar results. And then a more recent, even more momentous advancement was with the transformers, for example, which are somehow able to give more, to be context, to be aware of the context when they convert words, phrases, sentences to numbers. So a transformer would be able to look at the whole sentence, the whole surrounding of a word, and it will probably translate this free in a different way than the free as in freedom. So it is context aware. But anyway, let's stick to today because there is something more to see. Okay, so what we do to train? First, we have to prepare the data set for training because the network itself does not know words. So we have to somehow make a sentence into numbers. And to do that, there are various ways. I hinted at some just now, but what we use today is a tokenizer. So we will just create a tokenizer that cleans the sentence and associates every word it finds to a number. So every input sentence will become a string of integers. We will then pad with zeros. So the input, the labeled training data will become a string of integers for the input sentences. Also, the column ham, spam will become a column of numbers. And notice that we have 2 columns actually because we use the so-called one-hot encoding. Instead of having a single column with the various values of the classification result, we prefer, so the network works better if we just have a single column for every possible result with at most a single one moving around, as you see here. And the tokenizer itself will be trained, if you want, so will be made to best cover up to a given number of possible words. So the tokenizer will be not aware of the whole words in whole vocabulary, but let's say the 300 most used words in the label training data, and everything else will be dropped. And hopefully this will not be a big problem. We also split, and that will come important later. We also split training and we split the input data set in 2 parts. You will soon see why. And I think with that, we can start and train the model. Something that I didn't see is that there is a whole part preliminary to that, because even just getting this cleaned data set with sentences and result is work in itself, and sometimes a rather boring work at that. We did that for you today, so we will start with a cleaned data set. And for that, I'll leave to Rags for the training.
All right. One thing I wanted to mention, I really want to thank everybody who's on the chat and helping each other out, because this is a field with a lot of terminology. I think Stefano has done an excellent job of trying to do as much and not more, right? But there is definitely a lot more that we can cover. But really, thanks for helping us out. With all the different terminologies and where you can get more information and so on. This is really, after all, as much your workshop as ours. So thanks once again. So what I'm going to do is, do I prepare the data set for training? So I have to go into Git pod, right, Stefano? Yeah, okay.
Yeah.
Okay,
Yeah,
so
right.
what I'm doing is,
Yes.
once I've created the database, right, you're all up and running, right? Now I load the project into Git pod. To load the project in Git pod, all that I do is I hit Control click on Git pod button, as you can see here. So I can say open link in new tab, I can open link in new window, open link in new private window, whatever you want, pick whatever you like, okay? I'm just going to show you a quick one of open link in new window, okay? And essentially what it does is it opens up this link.
Rags, sorry. I think you are still
Thank
showing
you.
my
Yeah.
screen. Okay, sorry
No
guys.
worries.
Maybe you can show the Git pod
Yeah.
button, but maybe I'll paste the link anyway.
So let me go back. So if you go back to the Gitpod link, what you're going to do is you're going to control click, right? And you can open link in new tab, or you open link in the new window, or you can open link in the new private window, whatever works for you. Usually I go with open link in new window so that, I have Gitpod in another window, but I have running it in a new tab. It'll ask you for some of the credentials. You can use GitHub and get in, right? I'm not going to show you all that, but essentially, once you do all that, you're going to get a window that looks something like this. And if you have any trouble, opening this, what you can do is you can again, copy the link, okay, and you can put it in explicitly yourself, okay? So if you put it in like this, basically what it is it's gitpod.io and pound, as you can see here, the GitHub link, okay, workshop, AI as an API and so on, okay? So don't need to worry about any of that. All that you need to do is, like I said, hit control and the right mouse button, right? And you can open link in new tab, open link in new window, and so on and so forth, okay? So once you open this, you will see something, which is what we call as the Gitpod window, okay? And you will see here, essentially, you have all the, different artifacts that are required to run the workshop. We actually have done the install, and all of this is done for you automatically. We have something called as Gitpod YAML, which essentially does all this, installs for you. And basically you'll be dropped into something that looks like this. Okay, you can have multiple shell windows as they're referred to, but essentially it'll be dropped into something like this. Okay, and let me clear this. Okay, and if I just do a get remote minus v, okay, this basically tells me what remote repository I'm cloning here. Okay, so if there are some changes, I can git pull and all that. These are all git commands that you don't need to worry too much about it. But if you want to use this as a de facto editor, you can do that as well. It is Visual Studio. It's Visual Studio running in the cloud. And we have done workshops where we show how you can do debugging, profiling with Visual Studio. You can do find in files, just like any other editor. Nothing to install locally, but everything is available on the cloud. Okay, so I've said enough of that.
Okay, just one.
Yeah.
Sorry, Rags, I have to interrupt you. A few of you are reporting versioning errors between TensorFlow, NumPy, and 6. Yes, I've seen the same, and you should be able to ignore them because these I tested. You see the errors, but you know how Python is. You start having more than 2 packages in a Python requirement files, and you will see these errors. But somehow, in many cases, everything works out, and today is going to be the case. So ignore these errors, and let's go forward.
Absolutely. Yeah,
Okay,
yeah.
so
I didn't show any of that. I mean, I'm from the Java side of the world, and when you bring this up, Maven essentially brings the entire world in here, right? And you might see something,
yes,
a lot of things coming in. Ignore them for now. If it doesn't work, then you can always go back and fix it. But I think you should be good to go at this point. So how do
yeah.
I know that training takes a long time, so I would rather get you guys started on the training. So to be able to do that, I need to be able to. Does the training require me to download the bundle, or I don't think so, right? Yeah.
No, you can start with the prepared data
Okay.
set.
Okay.
Stop,
So
stop,
let's
stop.
start with the prepared data sets. Okay. So again, basically what I do is I follow the steps, right? I open the Git pod, right? Essentially,
I think we can keep inspecting the data
yeah.
set. So we go to the important part.
So it is available as a Jupyter notebook, as you can see here too. We are not going to cover any of that because we just don't have the time today. Okay. So
yeah.
can we jump straight into the train model?
Now we have to prepare the
dataset.
data
Right,
set.
right.
So go. No. Earlier. Sorry. A bit earlier. Yeah, here. So there is a step to prepare the
Right.
data set, which is basically what. Yeah. So here you see the Astra man here.
Yeah. So the
Yes,
Astroman will tell
exactly.
you
Python
what
prepare
exactly
dataset.
to do next, right? So I go
Yeah,
here,
the key steps.
and essentially what I do is I cut and paste from there. Okay. First
Yeah.
time around, it might ask you, is it allowed and all that. Just say yes. Okay. And then I'm preparing the data set now. Okay.
Okay, so basically, yes. If you are interested in further steps and further insight, please go have a look at the README. These steps does what we saw so far. So it makes the sentences into a big block of numbers. It prepares and saves the tokenizer and so on. You will also see a few things printed just for you to later inspect and see what is going on. These steps is also available as a Jupyter notebook. So if you want, you can alternatively run it as a notebook. So again, go looking into the README and you will find all details you need.
Yeah. So this Jupyter notebook can be accessible through Gitpod as well. So we'll not get into all those details because there are different combinations there. So I
want
know
to
that
get
you
to the
all are
important bits.
eagerly waiting to train the model. So I'm going to get into it right now because that's the heart of it. And it takes quite a bit of time. So what I will do is I will run the command. And again, all that I'm doing is taking these commands, right? I'm copying it and I'm putting it in what we refer to as the terminal window, okay? On Gitpod, okay? So let me clear this. So this was the output from the previous command, and I just do the Python train model.py. Okay, so I'm running the train model, and if you want, you can go check out what exactly this is doing, right? You can look at the Python file and see what this is doing. Essentially, it's importing a bunch of different modules, right? And then it basically does the fitting and the training that Stefano was alluding to, and he also has a way in which you can kind of get a little bit more details by uncommenting some of these lines. So you can try those and try it yourself. But what you're going to do is you're going to do this Python train model.py, the train model, run this. And once you have this up and running, just give us a few thumbs up because this takes like a good, maybe anywhere from 7 to 14 minutes, right? We have not done this with, so many people. So it might take a little bit longer, or it probably doesn't really because, this might all be distributed in, different regions. But once you have started the training, give us a thumbs up. And if you're stuck, let us know as well, and we can see how we can unblock you. Okay?
Okay. I see a lot of training started.
Perfect.
That's great. You probably notice it is not an instantaneous thing. Indeed, I'm going to quickly go
Yeah,
through
you can see here mine is running
some details of the training. That's okay. take a moment to notice the output. And again, if you want to see more, all scripts and notebook are there for you to inspect better, but I'm sure we now make a better use of our time if we switch to, yes, thank you, to the slide. So, okay, so training is going, very good. If you look into the training script, train model, you will see that there is a part where the network is created. So the network structure is created in code, and this is the relevant snippet of code. Basically, what these lines do is they initialize network as a stack of layers. So basically something similar to a feed-forward network. And then layer after layer, the network is created with a layer that basically is the input layer, then a dropout layer that is what implements the dropout. What is dropout? Dropout is during training, you switch parts of the network off at random just to avoid, the whole knowledge of the network being concentrated in a single part, a single neuron, possibly. And because that would be a fragile architecture. Let's say if you switch parts of the network off and off at random, you are sure that the knowledge, the skill of the network, the skill of the model is evenly spread somehow, which means that it will be more resilient to new inputs, more or less. Then you add the LSTM layer, which is recurrent because it has loops, but it is recurrent within the layer. So in this architecture, it is still a single layer. Indeed, you see this gray arrow that tells us that input information flows layer through layer until the final point. And the final layer is just it's just the layer that takes the information from the LSTM and makes it into a two-dimensional, a two-signal output. Basically, it will be spam or not spam numbers. Okay, so this is, of course, very schematic, but I saw a question, how do we alter the architecture of the network? Well, you might want to play with this part of code and rerun the training. Okay, so a few more words on the training while it is running. We already saw that training schematically means we tune the parameters so that the predictions are very close to the labeled data, right? Which means that we need to somehow find a way to measure how close the predictions are to the labeled data. And you see this blue function in the sketch here, the function that we are trying to walk to the bottom of the valley. This is exactly that. So this is a mathematical way to define how close the results from the model are to the real thing, to the training, to the label set. And this is what is called the loss function, or in some cases, cost function. And well, there are a few choices, but in particular, for the case of categories to choose from, so spam, not spam, for example, we use the so-called categorical cross entropy, which comes from information theory. You can think of it as the categorical version of a least square objective function, sort of. But you see, on the horizontal axis, there is these parameters slider. You can imagine moving this moving this progressively until you reach the bottom of the valley, and then you have won. The reality is that you don't have a single parameter to tune, and you don't have two parameters, as in this small sketch here on the right. You have probably short of 300,000 parameters, and you have to move somehow all of them in order to make the model match as much as possible the labels. And that's, mathematically speaking, is a mess, right? That's why there are specific algorithms that make it possible to find a minimum of a function in such a high dimensional space, basically, because that's what the problem is. The typical algorithm that makes this work is the stochastic gradient descent. So gradient descent means more or less you look around yourself in a point, you look where the slope is the highest, and you walk a bit in this direction. Then you repeat, you look around and you see, oh, this is the steepest slope, I walk here. But this is in It's not in 2 dimensions like you would walk in a mountain. This is in 300,000 dimensions. So that's not easy. To make this calculation feasible in a short time, there is also a stochastic component. So instead of using all of the input data set all the time, we do a random extractions of some points. We are using stochastic gradient descent, Dinesh. Yes. So instead of using the full input data set every time for evaluations, we use a random selection of these inputs, which makes everything works a bit faster. But that has an interesting consequence, namely that my training will be different from your training, right? Because of slightly different choices. Again, the results will probably match reasonably. So what is spam for me will spam for you, but not exactly down to the last digit. So my model is not exactly your model. That being said, my model will always give the same answer for the same question, and yours as well. I see a question about global minima. Yes, there is in principle the possibility of being trapped into local minima. Usually, given the shape of these machine learning problems, that's not a very common occurrence. So more or less, you have a half guarantee that you will eventually reach, or at least go in the direction of the correct global minimum. Okay, so I will skip backpropagation and dropout. Dropout we already saw. Backpropagation is essentially the chain rule of calculus applied to neural networks, becomes a powerful algorithm to adjust the changes in the weights in a coordinated way, but I can't elaborate more on that for time reasons. So some of you wrote in the chat about epochs,
yeah.
and yes. So well, basically the training proceeds through epochs, which are more or less sweeps over the complete training set, more or less. We decide to do 5 just because. In many cases, when you don't know yet what you're going to encounter, you might interactively decide whether to go forward or not. Today, we are going to make it easier, and we stop at 5 epochs because this is empirically working for this input. Okay, so one thing that we did, and I also show the relevant line of code, we take the input label set and we split it into 2 parts, the training set and a smaller test set. Why do we do that? Well, we do that because we actually do the training giving only the trained part as input. And periodically, we validate how the model works with the test set independently. So the important thing is that the test set is not used in training. It's just used to probe with an independent set of data to probe how the model is working. Indeed, in the output, you probably see 2 kinds of values being printed at each epoch. You see accuracy and validation accuracy. You see loss and validation loss. And they should more or less go the same route. So they should both follow the same trend. If they don't, like in this inset here, then you have a problem because you have overfitting. What does it mean? Basically, it means that your network is not learning to solve your problem anymore. It is just learning to mimic that very set of lines you give in training. And then with an independent test set, you bring this in evidence. And then it means that you had to stop before this takes over. So the problem of overfitting is this is a way to keep that under control. Okay, I think we could do a few slides on the API part, and then we go to the final part of the practice, so that your training will still probably still running. We will probably have it finished by then. So let's move to part 5, bring the API. So bring the model to production with API. Well, here there is not much to say, so not many slides, at least, because I would like the code to speak for itself, and there will be time to just see a few points in the code, and most of it will be in the README, I think. So there is an extensive explanation of many things in the code. Okay, so we finally, let's say we finished the training. Okay, so there's a question, where would you recommend we delve into specifics? If you look into the README, there are a few more paragraphs on the details of the FastAPI implementation and how the API is structured. And so most of them will have links to the relevant documentation. So maybe that might be a good starting point, that and inspecting the code and maybe experimenting with that. I want to say one thing, the FastAPI documentation is famous for being one of the best documentation of Python packages ever. So it is a pleasure to read. I mean, it's very good. So it brings you by hand through all of it. So it's a suggested reading, let's say. Okay. So back to this sketch. We have at the end of training, we have our mad scientist finally ready. So the model is ready. So the model is wrapped into a neat black box, and it's given to the engineer who loves API and has already in mind the full architecture that we know already. Now, in the architecture, from the API point of view, the model, the classifier is a black box, and we respect that, and we put this box in the sketch. So now it's a matter of how to structure the code which is ordinary Python code. And here you see the sketch of the modules at play and their various dependencies. Basically, main is where the API is created. The API object, the FastAPI object is created, defined, and where the routes are defined. So that's the main point. This is the module that we would give Uvicorn when we start the API. Then there is a config, which is a simple module that is able to fetch configuration from a .env file. There is a schema module that defines objects and data types. So complex data types are defined there. And there is a very nice package called pedantic that assists us in data validation. So request bodies and response types are validated in their schema, which is good. By the way, pedantic plays very well with FastAPI. Then we have the database access part, which, okay, it's rather simple if you want to inspect. There are functions to write and read data from the tables. There is the definition of the models. You remember these Python classes that abstract over the rows in the table. And there is a module that creates the database connection using the connection secrets, like bundle and the token secrets. The last point, and you see here with the black box in the balloon, is the AI model. That's a class that wraps the model itself. So we have the trained model will be saved as a bunch of files, tokenizer, and so on. And the weights, which is a big file with a few megabytes file with all of the numbers for these network parameters, that's a file. What you do in Python is you load it, and you load it with TensorFlow specific functions to load a network from a stored file, and then you can use the predict method on it. But there is a bit of pre-processing, because what the API receives is a piece of text, and it has to be made into numbers, you remember, to be later given to the network to extract the results, spam ham. So what the network actually eats as input is numbers. So we don't want to write the logic for this pre-processing of input text more than once. So we wrote for you a class that abstracts this text pre-processing into this AI model.py, which is a thin wrapper around the model, and it makes it possible. So it offers an easier interface to users, or more than users, to the main application, the main API. This model class, you might want to inspect it because it's by no means specific to text spam classification. It is general and reusable for any text classification problem, basically. So you might want to really use this. I think that's it. So there are a few nice features of FastAPI or the way it is used. So how to save the trained model. This is done for you by the end of the training script. You probably want to look at it. It's very simple. There are a few methods save offered by Tensorflow. So you train the tokenizer as it is, and you train and you save the network weights as they are with specific methods offered by Tensorflow. So it's very easy. There are actually various formats, but today we stick to the HDF5 format, but that's detail. Okay, so there are a few nice things in FastAPI. Caching, you will see how it works. Let me just quickly mention two things. One is that if you take the care of documenting, of commenting your functions and adding a few properties to the API, you will get for free a well-done, a well-made API documentation that you can directly expose. And it will be interactive. It will make it possible to issue requests for testing and so on. So the Swagger API, which is a standard, an open API standard. So this is all done for you by FastAPI. Another cool thing is that you can have this transfer chunked. So you can have a streaming response in FastAPI very easily. Let's say you have a very big input from the database. So a very big call log from the database, and you want to return it to the caller. You might do it in a streaming way and FastAPI has native support for that. But okay, all of this is explained in more detail in the README. So I think with that, we might go to the last part of the hands-on, and assuming the model is trained and saved, it's time to configure the API and start it and do a couple of requests. Rugs, to you.
All right. Let me see if my training is done. It's still working on Epoch 4. So it's taking a little bit longer, but why don't I kind of walk through the instructions that way, let's assume that it's whenever it's done, we can do this. Essentially.
Okay, if you prefer, you can also set. There is a setting in the .env that makes it possible to mock the model if you want. But why don't we start by setting up the secrets, the .env?
Yeah.
I think by then
so that'll be useful anyway.
It's probably going to be ready.
Okay, so let's do this secrets that you will need, and remember we talked about kind of downloading the zip file, which seems like ages ago, right? But essentially what we are doing is we are downloading the zip file locally and then moving it into Gitpod, okay? And all of this again is explained in the instructions. So what you're going to do is to expose the API, we need to be able to configure the .env and the DB Connect bundle, right? So essentially what we do is locate the file on your computer, whatever, Finder, Explorer, whatever, and drag and drop the bundle into the Gitpod Explorer window, okay? So I'm going to go back to my Gitpod Explorer window. I've already done this before, but I'm going to show it again, okay? So I'm going to go to my Finder window. Okay, there's my Finder window, right? And I'm going to go back. Okay, so I know what's going on here. Give me a second. Yeah, so let me take this out of full screen. Okay, and now locate the Finder window. Find the secure connect workshops.zip, which is the the connect bundle that you downloaded earlier, and drag it and drop it here. This is the easiest way of doing this. Okay, there are some other ways of doing this, but this is what we recommend here. And you can see here, the entire thing got highlighted in blue, right? And if you drop it here, of course, this is say, do you want to replace it because I already have it? I'm just going to cancel here, but you can say, it probably won't ask you if you have not downloaded it. So the way to verify that you have done this right is just go back into your, again, just all that I do is cut from here and paste here. Make it as easy as possible for you. Okay. You will see here that there is a secure connect workshops.zip that you are copied, and it's about 12,000 bytes long, right? Obviously, I downloaded it like a week before when I was preparing here, but you should see that date to be today if you just downloaded it. Okay. Did I miss anything? And the next thing that I want to do is copy this env.sample into .env. Okay, so I've done all this before, but I'll kind of walk you through that. So here's my .env.sample. Okay, so I can do more. And you will see what it is. It has a whole bunch of stuff in there, right? I have to update my key space, my DB bundle path, my client ID, and my client secret. Okay, those are the ones that I need. Okay, let me open it here, which will open.env.sample. Okay, so we have prompts for you to add these database access parameters. The key space is already populated for you. The bundle path is already populated for you. All that you need to do is update the client ID and the client secret. To do that, again, follow the steps. Copy the env.sample, cp.env.sample.env, okay, and just say gpopen.env. So what I'll do is I'll do exactly the same, okay, which is copy, right? And assuming I've done that, then what I can do is I can just say open the .env. Okay, I've already made this changes here, so if I do the open env, you can see all the information is in there. But essentially, what I did was I went back to where I had it as a remember as a spreadsheet, or where I put it, and then I copied the token, the secret, and that's pretty much it, right? I needed to do the client ID and the client secret, and you're good to go. Okay, so this will help. This will actually enable us to connect to the Cassandra database, right? And once I have this running, and let me see if my my training is complete, and you will see here I'm basically flipping between these different two tabs. Okay, you'll see that my training just completed, right? It took a while, but it did complete. Okay. And what I'll do is I'll skip the step where it talks about kind of the minimal API. The minimal API, you can see, you can kind of walk through this. There is a main.api, okay, and it has different endpoints like the endpoint of slash, the endpoint of slash prediction, and the endpoint of slash predictions, okay, with S in plural, right? And then you have the main.api, which really is the main API. And this has a little bit more than what was there before. It also uses a way to tokenize, to authenticate to the API. So it essentially asks you to provide a token, and only after you're authenticated you can do invoke the endpoints. There are also some endpoints that are added here, like for example /recent log. And I think Stefano talked about this. You can play around again with this code. Unfortunately, we don't have too much time to kind of dissect the code, but all of this is available in your Gitpod window if you want to play with this. You can kind of look at the AI model. There are different Python, Python programs here. So here's the DBIO. So all of this, you can kind of take a look at this. And play around with this. It's available for you. So the next step is kind of getting the API. So like I said, I'm going to ignore the minimal API and go straight into the full API. Okay, so to use this or to be able to provide this, we use something called as Ubicon. And again, when Stefano talked about the technology stack, he talked about this. All that I need to do is let's see if this works, is again, do a cut and paste, right? I just run this, and what this does is it invokes the API main, which is right here, right? And essentially invokes the program, right? So let me start this off. Uses the training, the model, does all that, and I got something wrong here. Let me see what went wrong here. What's a live demo without something going wrong, right? Did I miss anything here? Oh, should I go into API?
Did you set the .env?
Oh, maybe that's what I did. I forgot.
That's
Yeah,
probably it.
thank you. That's what happens if you skip the steps, right?
So it doesn't. Yeah. Well, the .env is essential. Unfortunately, you have to tell the API how to connect to the
Right.
database. It wants to speak to the database, but maybe you can just run the minimal API and we do without
Right.
database.
Yeah, just give me a second.
So if you want to just copy the .env,
Yeah.
that's it.
Let's see if
Don't,
I'm missing something else here. I think I did that. Okay. So let's run this.
okay, so you can start the minimal API.
Let me start the full
Go
API.
up.
Let me try that first, right? Okay. So this is not it.
Okay. No, you have to cd dot dot.
Gotcha.
Yes.
All right. So
That's
let's try
where
this. This is what.
Okay. Now it should
Yeah.
work. If you put the .env, that should work.
Okay. I'm not sure.
okay.
So
No. Okay. You have can you show your .env? I think it is missing a last line. Maybe this is a. Yes. Can you open the .env sample and copy the last line over to .env? I think you have a Git pod that is. You created it before
maybe,
a
okay.
few commits by me.
Thank you. I should have. So model class is equal to 0.
Yes. If you add these to the .env, it will
Perfect.
presumably work.
Okay, let's try that. Debugging on the
so
fly.
probably to all of for all of you, Uvicorn should run because you created the GitHub, the Git pod environment today. But Rags, of course, was testing it a few days before, earlier, and so the .env, which is outside, which is in git ignore, was not updated with the latest.
Okay. Now the moment of truth.
No need to source, by the way.
Because it's
it will just
automatically
work.
run. Right.
Yeah. You see a lot of things happen.
Yeah, and I'm failing there.
Okay. You know what? You also have your old, the table is old.
Right. So in the interest of time, do you want to take over and do the Git pod, part of it?
Maybe. So give me time to make it work, to make it start, maybe. What? So yes, it will start in 1 minute. Okay. Okay, so these are a bit of last-minute points. The point is that in the last days, we've been changing a bit of the data model, and now Rags's table is not exactly matching the schema. So the driver complains, and it doesn't dare destroying the table as they are. So that's the point. Okay, I'm showing mine. I think it is starting. Okay, so it should work.
Perfect.
You see a lot of output. So what happens during startup is two things. The model is loaded by the API code. The model is loaded, and maybe I can try to make everything a bit easier to read.
Yeah.
The model
I was going to say maybe the font a little
here
bit.
In this part. So this is where we initialize the API object. And also something that will happen only once is that we will load the model in these global objects, spam classifier, which is then, this is an instance of the AI model reusable class. Okay. At the same time, also in initialization time, we also prepare the database object so that the table is in sync with the object definition, and we are ready to just read and write cache items and so forth from the database. So there are various ways to test this API, which is, as far as we know, is running. Let me get rid of this. The easy way would be, so the hardcore way maybe would be to curl, like I'm doing here. I'm just asking an slash endpoint, which tells me a few basic information, including my own identifier. No big deal, but I might want to try and do a bit more. I might want to do some more cool things. So, for example, let's say I want to do a request to my API like this. Why not? So there is an endpoint for multiple text with these slash predictions. Let me show you how you do that with command line curl. Yes, so this is it. You see, it worked. What happens is that we send a request with the body containing those two sentences to classify, and the output tells me that click to win a free car is spam with 87% confidence, and I like this endpoint is ham with 95% confidence, and that's very good. I apologize to those saying they have errors, but we will be reached on Discord, and please have a closer look at the README instructions for that, because I think we are a bit late on time. I just want to show you one thing, and then we will close for today. And again, we will accept and discuss a lot more in Discord if you want. But issuing curl commands is not the only way, because as I quickly mentioned, you can also FastAPI directly offers an interface, a Swagger API. So a Swagger interface conforming to the OpenAPI specification, which means that for free, by running the API, you will also get this /docs endpoint that is an easy interface to try endpoints. Besides checking the documentation, you see every comment, every doc string in my endpoint function ends up here, and every schema definition is used through pedantic is used to create a meaningful documentation. You see, for example, let's see the predictions endpoint here. Maybe I'll make it this bigger, but the predictions endpoint I can also, so it tells me a bit of details for documentation for the endpoint. It also tells me the schema that I have to use when I pass a body to this request, and I can also try this endpoint out here live within the documentation. Let me just click execute, and magically, here is my output. You see, within the documentation is ham. Yes, for sure, is ham. And that's just something I can do here. So it's good for debugging, for exposing the API documentation. I just want to show you very quickly that if you repeat this call, you will notice that the first sentence, now this is the second time I call this, and it is coming from the cache, while this one, the DDD, is coming not from the cache. So the model has been run only on the second sentence here. And I can play with these and have a look at the recent log, which I can run like this. And I will know the history of my calls. So within, yes, for sure, within DDD. This is exactly the log of the calls. And this is also coming from the database and being served to me by the API. All of these in a production level API that exposes the model, and it also offers this neat documentation, basically generated by looking at doc strings throughout my code and a few other small things. Okay, so as I said, there is a lot more to be explored in the README. Of course, this was barely scratching the surface and getting you started with the two phases of both, let's say, training your first classifier model and making it into a real working API.
So Stefano, I know
there's much more to do, but
yeah, I know we're already beyond.
Sorry.
But I just wanted to tell you that while you were, gladly stepping in for me, I was able to debug the problem. Essentially there was a problem with the schema, so I dropped the tables. So you may have run into the same issue as well. So if you drop the tables, it'll automatically recreate it for you. And now I'm essentially in the same. I'm able to run the API, and Stefano talked about how you can kind of walk through these different Swagger calls, right? And I basically did the same thing as well. I executed this. So if you're running into trouble, maybe what you can do is you can go into SQL, and essentially what I did here was I dropped these two tables.
Probably that's not relevant to those of our attendees who started today, because your problem comes from having created the tables earlier.
If any of you have done it before, you may have run into that. But yes, so let's. I know that we are already way past time. So Stefano, I will hand it back to you. Just give me a second.
Okay, so everyone who can't run the API, like Lividian here. Of course, for time reasons, we beg you to reach us on Discord, and we will be happy to help you and troubleshoot your execution and go through the steps in the README with more time and attention. Okay, so let me close. We might have, we just have a few final points. One is the quiz. So those of you who endured and are still with us are awarded a chance to win prizes. So
I'm going to start the quiz music, and if it's too loud, let me know.
So again, we invite you to join us on Menti again. So in the meantime, for those who have to leave, this is the link to join us on Discord. In the meantime, I hope many of you are joining us on Menti, which also the link to. So menti.com, and then you enter the code that you see on screen. So now I hope we've been showing you everything you need to be able to answer the questions. This time the questions are on what you learned today, of course. And there are prizes for the first 1, 2, and 3 in the leaderboard. And remember that you have not only to answer correct, but you also have to answer fast. And now we start with the quiz. So please join us here to Menti. I think we can start gathering you to join. So I'm glad to see that most of you in the chat managed to have everything working. If you didn't, you probably just have to go slowly through the instructions, because I appreciate we had to rush a bit through various parts. There was indeed a lot of stuff. Okay, so I think we can start, and there are 6 questions, and get ready, flex your fingers, and be ready to answer correct and fast. Today, we saw an example of image recognition AI, supervised learning, random forest, unsupervised learning, or a ballet by Tchaikovsky. Remember to answer on your phone.
Don't put it on chat.
Otherwise, your answer is lost. So, supervised learning, very good. Ballet by Tchaikovsky, I wish, or you wish. So let's see after this first question, how is the leaderboard? And Pavan is leading, but there is still quite some ground to run.
Yeah, anybody, Azman, White Giant, Siva, Cash, anybody, could just pop up there. Again, just answer fast and answer correct.
Yeah. Siva, sorry, but your answers on YouTube will not be counted because you should be on Menti. And if you miss the code, maybe it's a bit too late now. Sorry. Okay. So next time. Question number 2. The text classifier model is trained within the API, or is a feed-forward neural network, or needs no training. It is designed to have memory, or I cannot tell you it's classified.
Boy, all of them
Let's
look like
see.
it's possible.
Think carefully. Yeah, absolutely. Especially the last one is designed to have memory. Yeah, it looks a bit like a feed-forward, but there is an LSTM layer, so it is indeed these loops in the signal that make the trick and may give it memory. So yes, it is designed to have memory. And it is not trained within the API code, but rather before that. Remember, the crazy scientist does that, and not the engineer.
Stefano, you really managed to, stump a lot of the natural intelligence there, right? So.
Okay. Okay, so Chandu is the fastest, but now Kriti is in first position. And very congratulations to all of you who are not fooled by the way we phrase the questions. And get ready for question number 3. To train the model, we called the train method, we called the fit method, we called the optimize method, we called the predict method, or we set the xtrain and xtest model properties, or we have to write the full training algorithm ourselves. Maybe Rags, we didn't pay too much attention
let's
to this
see. Let's
point.
see if this works. Yeah.
Yeah, we call the fit method.
That's kind of showing you here, right?
That was a bit hard. Maybe some of you had a look at the code, and this is your reward, Let's see what happens to the leaderboard. We can imagine
some changes.
But most of you managed to answer correctly.
Yeah.
And Adam jumps to first position, but Kriti follows very short. Brandon, I'm sorry to see that. Okay, so
still
question number 4.
3 more, right? So we still got 4, 5, and 6.
Yeah, but there is always next workshop to play again. Question number 4. We use a database called Keras. Or actually we don't use a database, or maybe it's called AstraDB. It is a middle layer between the API and the classifier, or it is built on Cassandra.
Looks like it's possible built on Cassandra.
Looks like,
Nice.
So almost everyone got this right. So the database is called AstraDB, and it is built on Cassandra. So congratulations.
Nobody got it wrong, huh? That's cool.
Yeah, so the database part, and we are proud of it, was given enough time to make it clear. Very good. So Adam stays on first position, Julian and Kriti second and third. Okay,
everybody's game still 2 more left.
Okay, question number 5. Answer fast to get more points. So using the Cassandra driver's object mapper, you can forget about the table structure, or there is not even a table involved in any sense, or maybe still a proper data model must be chosen, or using the object mapper is an alternative to the NLP classifier.
Tricky. Looks like I can forget.
Yeah, okay, that was hard, I know. Still, a proper data model must be chosen. So we say that, yes, you can forget about tables in reading and writing, but still, when you plan the object, you have to think about the data model. Otherwise, your performance will be possibly terrible and probably not very optimal. So this shattered a bit the leaderboard, but let's see. Adam and Diogo Nascimento and Chandu jump to the first 3 positions.
Wow.
Congratulations.
The leaderboard was totally overawed, huh?
Yeah, I like to put
tough questions.
Tricky
questions
by the end. Otherwise, where's the fun? Question number 6. Okay, so what are notable features of FastAPI? Streaming responses, request body validation, mostly scriptable in COBOL, or cool support for OpenAPI and docs, or maybe it has native support for Golden Dolphin. We saw many of those, and yeah, so it is not scriptable in COBOL, as far as I know. And as for Golden Dolphin, I want to know what this is, because it's a name I made up, and I made sure there is no relevant software product with that name. So I really don't know what Golden Dolphin is. Sorry, that was a bit mean from my side, but still, that's the way it is. Okay, so leaderboard.
And these are the winners,
Leaderboard.
right?
And so last surprises: Adam, Ron S, and Chandu, first, second, and third position. Congratulations to you and to everyone for attending. Congratulations, and thank you for staying with us until now. Please, the first, second, and third position, please take a screenshot of your winning Menti score, your winning screen with the Menti. Take a screenshot now, because later you will be required to send this screenshot by email as proof to this address that you see in a second in the chat, and you will be able to claim your swag. To everyone in any position in the quiz, congratulations, because you are walking home with, I hope, more knowledge and more experience, and you will be probably ready to play by yourself. Now the road is wide, and actually there are many roads to follow, so have fun. There's a lot to learn, and I will leave the Menti open just to collect a bit of feedback, free form feedback. What did you like? What should we improve? Just to, tune better the next workshops. And in the meantime, while this, I want to close with just a few slides, and thank you for your patience. So winners, please send the screenshot to this address you saw already in the chat, but it's also here in the slide. Okay. So we run a workshop every week. So next week is going to be an e-commerce application, which is part of you can't get the screenshot anymore. Yes, I moved forward after a little while. But Ron, you probably write an email to Gary anyway and tell us who you were in this quiz. Okay, so we run workshops every week. So these are the next episodes, and please join us, because there is always a lot to learn. And special announcement: 2 days ago, a long-term hackathon started, a build-a-thon, which is lasting a few months. So there is absolutely still time to, you missed the screen too, Menti crashed. So, okay, so those of you who had problems with Menti, send an email to Gary, and let's see if there is a way to secure your identity. Maybe you might want to add a feedback with your email address in the current Menti, if you manage. So the link to the next workshop is here. Should be here, if I remember correctly. There should be a link to see all of our upcoming calendar. So there is an hackathon, and again, there should be. Yes. So in the YouTube chat, you see a link to get up to date to our future workshops, and there will also soon be a link to this hackathon. There is real money in prizes, so a few $1,000s worth of prizes. So please consider joining us. So it's here. The link is in the YouTube chat. It's going to be fun. There are 3 different challenges, 1 per month. And you can do whatever challenge you want. Form a team. You can come with your team ready or not, and it will be The only constraint is you will use AstraDB as database, which you know after today, right? So no big deal. Yes, this video will be on YouTube for future viewing, sure. As we said already, please join us on Discord so we can carry the discussion forward, because that's a chat that is not disappearing when this video is over, which is very soon, as you know. Of course, we ask you to click the thumbs up and maybe to subscribe to our channel, because we push out content every week, and if you like what we did today, there's going to be a lot more. So that's it. Now, a last important point is about homework. Now, before we say goodbye, homework. In the README, in the repository, there is a full explanation of the homework that you have to hand in to get your badge. It's nothing complicated. There is a form for submitting. Yes, you see here in the chat, you should go to this link. The homework, the submission form is a few theory questions, nothing that was not covered today, followed by a small assignment, a small lab, where you have to code to extend the API and show us proof that you made it work with this extension. After which you will submit the homework, you will click submit, we will grade it, and you will be awarded a badge. So that's it, as far as the homework is concerned. And I think that's more or less all. Rags, what do you think?
No, I think we got pretty much everything. Again, I know that we are a little bit beyond, but hopefully this was really useful. I know we barely scratched on the surface of AI, ML, and all that, but hopefully it gave you a feel for how you can do the ML ops, which was really the goal for today. And you were able to build an API and kind of connect all the dots together. That's it.
Yeah, I appreciate you staying with us until now, and sorry for being a bit late. I hope it has been time well spent. And with that, I think we can tell you goodbye and thank you. And thank you, Rugs.
Thanks, everyone. Bye.
It's been great. Guys, take care. See you next time. Bye-bye.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.
No problem. I didn't think of that myself, so no big deal. I think you should